I'll be going over bone growth, starting with the functions of the skeletal system. Bone, also known as osseous tissue, is a hard, dense connective tissue that forms most of the adult skeleton. The skeletal system is the body system composed of bones and cartilage and performs the following critical functions for the human body. It supports the body, facilitates movement, protects internal organs, produces blood cells, stores and releases minerals and fat. So its functions support movement and protection. The metabolic functions, mineral storage, energy storage, and hematopoiesis. Important for all of the bone tissue is nutrition. Calcium and vitamin D. Calcium is a critical component of bone, especially in the form of calcium phosphate and calcium carbonate. The body cannot make calcium, so it must be obtained from your diet. However, calcium cannot be absorbed from the small intestine without vitamin D. Therefore, intake of vitamin D is also critical to bone health. And vitamin D is ingested through either food, supplements, or manufactured in the skin after absorption of sunlight. Vitamin K also supports bone mineralization and may have a synergistic role with vitamin D in the regulation of bone growth. You can find vitamin K in green leafy vegetables. Quick overview of bone repair. When a bone breaks, blood flows from any vessel torn by the fracture. The blood then begins to clot, and at about 6 to 8 hours after a fracture, the clotting has formed a fracture hematoma. The disruption of blood flow to the bone results in the death of bone cells around the fracture. So within 48 hours after the fracture, chondrocytes from the endosteum have created an internal callus, pictured here, while the periosteal chondrocytes and osteoblasts create an external callus of hyaline cartilage and bone around the outside of the break. External callus is pictured here. Over the next several weeks, osteoclasts reabsorb the dead bone, and osteogenic cells become active, divide and differentiate into osteoblasts. The cartilage in the calli is replaced by trabecular bone via endochondral ossification. Eventually, the internal and external calli unite. Compact bone replaces spongy bone at the outer margins of the fracture, and the healing is complete. Although swelling may remain on the outer surface of the bone, the region may undergo remodeling and no external evidence of a fracture remains. And that's pictured here. To go over bone types, there are long bones, and they are longer than they are wide. It's here. Short bones are approximately equal in length, width, and thickness. Flat bones are thin and curved. Irregular bones have a complex shape, and sesamoid bones are small and round and are found embedded in tendons. So your long bones can be your femur. Sesamoid bone is a bone like the patella in the knee. Short bones are in your hands and feet. Irregular bones like your vertebrae, and flat bones are like your sternum. The type of bone cells in this overview of the gross anatomy of bone. Osteogenic cells, these are the stem cells that develop into osteoblasts. And the osteoblasts are responsible for bone formation. Osteocytes maintain mineral concentration of the matrix, and osteoclasts are responsible for bone resorption. Two types of bones are your compact bone. This is the denser, stronger of the two bone tissues. Spongy bone is also known as cancellous bone, containing osteocytes housed in lacunae. Blood and nerve supply. The spongy bone and medullary cavity receive nourishment from arteries that pass through compact bone, and the arteries enter through a hole called the nutrient foramen. In addition to the blood vessels, nerves follow the same path into the bone, where they tend to concentrate in more metabolically active regions of the bone. The nerves sense pain, and it appears that the nerves may also play roles in regulating blood supplies and in bone growth. The diaphysis is the tubular shaft that runs between the proximal and distal ends of the bone. The hollow region in the diaphysis is called the medullary cavity, which is filled with the yellow marrow. And the walls of the diaphysis are composed of dense and hard compact bone. And the epiphysis is filled with spongy bone, and that's where red marrow fills the spaces in the spongy bone. Each epiphysis meets the diaphysis at the metaphysis. The narrow area that contains the epiphyseal plate, which is the growth plate, that's a layer of hyaline cartilage in a growing bone. The bone stops growing in early adulthood, approximately 18 to 21 years old. And then at that point, the cartilage is replaced by osseous tissue, and the epithelial plate becomes the epithelial line. So here's the epiphysis, the proximal, and this is the distal one, and they always meet the diaphysis at the metaphysis. To cover bone growth, bone is a replacement tissue it uses a model tissue on which to lay down in mineral matrix. For skeletal development, most commonly the template is cartilage, and during fetal development, a framework is laid down that determines where the bones will form. So bones can be formed two ways, either through intramembranous ossification, which is when compact and spongy bone develop directly from mesenchymal connective tissue. The type of bones that form this way are the flat bones of the face, most of the cranial bones, and the clavicles or the collarbones. Intramembranous ossification begins in utero during fetal development and continues on until adolescence, when the bones are fully developed. The other type of bone growth is endochondral ossification. This bone develops by replacing hyaline cartilage. The cartilage does not become the bone. Instead, the cartilage serves as a template and is completely replaced by bone. And here's an image. This endochondral ossification follows 5 steps. So, how bones grow in length is called longitudinal growth. The epiphyseal plate is the area of growth in a long bone. It is a layer of hyaline cartilage where ossification occurs in immature bones. On the epiphyseal side of the epiphyseal plate, cartilage is formed, and on the diaphyseal side, cartilage is ossified. And thus the diaphysis grows in length. How bones grow in diameter is called appositional growth. And while bones are increasing in length, they are also increasing in diameter. And this growth in diameter can continue even after longitudinal growth ceases. Osteoclasts reabsorb old bone that lines the medullary cavity, while osteoblasts, via intramembranous ossification, produce new bone tissue beneath the periosteum. The erosion of old bone along the medullary cavity and the deposition of new bone beneath the periosteum not only increase diameter of the diaphysis, but also increase the diameter of the medullary cavity, and this process is called mottling. And that covers my review of bone growth.